I just finished my periodic table coloring activity, the last assignment from today, where all the S elements, where the configuration ended with an S, those were supposed to be red. All the ones that ended with a P, those are supposed to be green. D's were yellow, F's were purple. When I finished that, I got this. Isn't this interesting? If you did it right, this is what yours should look like. And look, everything that I colored red, all the ones that ended with an S, they're all in the same area of the periodic table. Coincidence? I think not. The P's, everything that ended with a P was green, ended up in this area of the periodic table. Everything that ended with a D ended up in this area, and everything that ended with an F ended up in this area of the periodic table. Okay? It's almost like the periodic table was designed specifically for electron configurations, and as a matter of fact, that's exactly it. You can see this on ptable.com. The default view on ptable.com is this properties view, but if you click over to electrons, you can see that these areas have their own color and they're named. This is the S block, this is the P block, this is the D block, and here's the F block, just like we discovered. Super, super cool. One thing that this means for us is that we actually have a shortcut that we can use for electron configurations. Okay, so this is so important, you should grab your class notes and throw this information in here. This is the S block, this is the P, the D block, and the F block. And what this means is that, like here, look at example 1, you don't have to add up all these superscripts anymore. All you need to look at is this last thing, 4p4. You see, if it ends with a P, I already know that whatever element this is in example 1, it's somewhere here in the P block. Okay? I also know that I've got a coefficient of 4 there, so I know that this element, whatever it is, it must be in period 4. So already, just by looking at the 4 and the P there, I've narrowed this element down to this chunk of the periodic table. It's somewhere in there. This is the 4p area of the periodic table. Well, how can I pinpoint exactly which one it is? That would be the superscript. Okay, so I'm going to go to the 4p region, and I'm just going to add this to our notes here. By the way, there is no 1p, so I screwed up my drawing here. There's a 2p, there's a 3p, 4p, 5p, 6p, 7p. I'm going to try to fix this square here. There we go. That's about right. This says that in the 4p subshell, this element has 4 electrons. And we know that every time you add an electron, you're moving one step to the right on the periodic table, right? This element right here would be the 4p element with 1 electron in the 4p subshell. Here's 2, 3, 4. Okay, so I've pinpointed that I just need to walk 4 steps into that 4p area. Now obviously that's much easier on a real periodic table, but let's take a look. Here's period 4. Here's the P block, 1, 2, 3, 4, and if I cheat a little on ptable.com, you can see that the last term is 4p4. So this is selenium. I didn't have to add up all the superscripts. Way quicker. Okay? So let's write that down quick. No need to add superscripts. Okay, just go to period 4, P block, comma, 4 steps in, and you're done. It's selenium. This also, okay, that's a nice little thing. This also means that we don't need to care. Since we don't need to care about all this stuff here, we don't need to write so much anymore if we're going to write an electron configuration. Okay? You can write them in a shorthand notation, which is really common. So this one says krypton 5s2. Well, that means I should start at krypton. And by the way, krypton is 4p6. See, period 4, p block 1, 2, 3, 4, 5, 6 steps in. And then go to 5s2. So here's period 5, s1, we're in the s block, right? s2. So again, super quick. 5s2 means it's period 5, s block, 2 steps in. We know it's strontium right away. And on top of that, we don't have to write all of this. If we're going to write our electron configuration ourselves from scratch, you don't need to write all that. You can just write krypton 5s2. Okay, because all of this junk is the electron configuration for krypton. It's a shorthand notation, right? Saves us a bunch of writing. Okay, so this, what did I just say? Strontium? Strontium. This is SR. Shorthand notation. You always have to start with a noble gas in the brackets. Okay, just so you know, that's the rule with this. You don't have to use shorthand notation. If you want to do the extra writing, go ahead, right? I wrote all this one, example 1 here. I wrote all that out by hand. No big deal. But if you know what you're doing, you can get things done a little bit quicker by using the shorthand notation. Always start with a noble gas. And you shouldn't just pick any noble gas, right? You should pick the noble gas that's closest to your target. So if I'm writing the electron configuration for strontium, I want to go backwards. This is number 38. Okay, trying to select that. 37, 36 is the nearest noble gas for that shorthand notation. And that's it. Probably we'll do a little assignment to practice this stuff, but now that we know the way the periodic table is organized, no more adding superscripts. Much simpler. Enjoy.